This is a coding tutorial on making a reinforcement learning environment in Python from scratch. So let's get started. So first thing, we are going to create the environment class. For this, we are going to need NumPy, and we are going to need Pygame for visualization. In this tutorial, we are going to be making a grid world. If you don't know what a grid world is, it is basically a n by n grid. There is a player that would be controlled by the agent, and there's a goal square. And when the agent reaches the goal square, it gets a reward of 1. It's very simple, probably the simplest environment. All right, so initializing this environment, we need a couple parameters. We are going to need a grid size. Let's default it to 5, and we are going to need a max steps. Max steps is, well, it is the max number of steps that the environment can run per episode, and it resets if we go over this max steps amount. Let's bring these in. And now we are going to need, the player position. Default it to 0 for now. Make it a NumPy array. And same thing with the goal position. Next, for the Pygame visualization, we're going to need a couple parameters. Could have this in a config file, but since this is a small tutorial in a small kind of environment, let's just keep it all in the same script. We're going to have a square screen, so only need one screen size. And then the grid cell size, about 50 pixels. We have a delay, and this is in microseconds for better visualization. Then our total grid pixel size is going to be the total length of the grid, so 5 times the cell size. Next, we need a offset to actually put the grid in the middle of the screen. So this can be the screen size minus the total grid size divided by 2. And same thing, we need a y offset, and it is the same. Finally, we need a couple colors. Again, this is all for the visualization. Use a white for the background. Use black for the grid. Green for the goal square. Oops. And blue for the player. All right. So let's start now with reset, which is the first kind of function that every environment needs. And reset is going to be pretty simple. First, it takes in a seed so that you can replay the same episode if you would like. Default to none means random episode. So this function resets the environment, and it just randomizes the player and goal position, and makes sure that they are not on the same grid square, or else the episode's over. So first we need to set the seed if it's not none. Just check if seed, and then we call random.seed. Next, we will initialize a random goal and player position. We will set the goal first, and it's between 0 and grid size. and right, there's X and Y, so we need 2. And the player is going to be the same thing. Let's just copy that over. And then we need to check if the player is on the goal square, so we will randomize the player position while it is still on the goal square. So we will check if the arrays are equal. Oops. And while they are equal, we will just set the player again. And we also have we need a step counter, so we need to initialize the step counter. So self.current step gets reset back to 0. Finally, reset always returns an observation and an optional info. We haven't implemented observation yet, so for now let's just return none and none because we have no optional info here. So the next function we're going to implement is get observation. This doesn't take in anything, and this function returns the current observation of the environment. So our current observation for this environment is going to be a unit vector pointed to the goal position from the player position. This is a good observation as it's very general, and the agent only has to learn what this unit vector means to be successful in this environment. So first we are going to need the vector pointing to the goal position from the player position, and we need this as a float because if you remember, the positions are int arrays. And then we need to normalize it, so we are going to get the norm using np.linalg. And then if this norm is not 0, we are just going to divide our vector by it. And then we return our difference vector as the observation. Next, we are going to write the step function, and this takes in an action. And this function takes the action and performs it in the environment. And the actions in this environment correspond to the 4 actions possible. So 0 is going to be up, 1 is going to be right, 2 is going to be down, and 3 is going to be left. So first we need to initialize reward done and truncated. Oops. Because every time you call step, it'll return the next observation, the reward, done, truncated, and info. So reward is the reward for taking this action. Done is if the environment is over, and truncated is if the environment is over due to max steps. That's the difference between done and truncated. So we are going to initialize these, reward to 0, done to false, and truncated to false. Next, we are going to get the new position due to the action, and we're going to initialize it to current player position. So if the action equal to 0, our new position y value is going to be +1. If action is equal to 1, new position x value can be +1. If action is equal to 2, new position y value is going to be -1. It's going to be subtracted by 1. And lastly, if our action is equal to 3, our new position x value is going to be subtracted by 1. Now after that, we will check if the player can actually move to this new square, right? It could be out of bounds of the grid. Position. So if the x position is greater than or equal to 0, right? If our grid is size 5, then it goes from the x grid squares go from 0 to 4. And so if it's greater than or equal to 0 and it's less than the grid size, and we'll check the same thing for the y position. And if this is true, we can set our new position, our player position to the new position. So now we need to check if the current episode is over. Basically, is this new position now on the goal? So we use array equal is our new player position on the goal position. And if it is, we are going to set done to true and the reward to 1. And now we can check for the truncated condition. Sorry, we need to, we forgot to increment step here. Now we can check for the truncated condition. If the current step greater than or equal to max steps, we're going to set truncated equal to true. Oops. And now we are going to return everything. So return, we need the next obs, reward, done, truncated, and optional info. So now we have our observation function. We can just return it like that. Return the reward, return done, and return truncated. And we have no optional info, so just none. And let's go back up to reset and return the get observation. There we go. So right now we have our full environment. We have reset, we have step. Now we just need to visualize our environment. So we do this with a render function. So first we're going to check if we have initialized our Pygame screen, because if we haven't, we are going to call pygame.init, and we're going to create our screen. Oops, oh, nope. We are going to set the screen size as a square, and let's set a caption as GridWorld RL. So now if we do have a screen, we are first going to clear the screen. by filling it with white. Then we're going to draw the grid by iterating it through and then we're going to create a square to represent, well, the square in the grid, the current square in the grid. And for that, we're going to use a Pygame rect, the current x times our cell size, plus the offset we had to put it in the center of the screen. And then if you remember, Pygame actually has its origin in the top left corner. So our y-axis is flipped. So we can't just use our y value. We actually need to use the opposite. So right, if y is 0, we actually need y to be 4 and keep flipping it between on the reversed axis because of the Pygame origin. And then we still have an offset. Oops. And then we just use our cell size for the rect size. Great. And then we can draw it. Draw it on the screen. We will draw it as black. Draw the rect. And with a border width of 2, so it's not a filled in rectangle. So that is the grid. Next we can draw the goal. It'll be kind of the same thing. So we're just going to get the goal x and goal y from the position. Then we're going to get the rect. Instead of x, we are just going to put in goal x. And instead of y, we're going to put in goal y. And then we are just going to draw it. So yeah, probably shouldn't be goal rect. Then we can do the same thing for the player. Oops. Oh, sorry, and the color of the goal should be green. So we're just going to draw the player. Should be player X. Should be player Y. And then we need to draw. There should be the player rect. Player should be blue. And there should be the player rect. And now we just need to update it. And add our little delay so we can actually visualize it better. Great. And then our final small function in our environment is close. And all this will do is just close the Pygame screen. Now that we have in our environment, we can use it in our main script. So first, let's import it. Import NumPy. And for our parameters right now, we really just need the number of episodes, and let's just set that to 2. Then let's initialize our environment. Just default for now is fine. And then for our records, we're going to keep track of the episode rewards. And now we can jump into our RL loop. So for episode and range num episodes, we'll start with resetting everything. So we need to reset the current episode reward to 0, done to false, truncated to false, and then we need to call reset, call reset on our environment. No seed for now is fine. And now we can jump into the actual episode loop. So while not done and not truncated, we are going to sample an action. Right now we don't have an agent, so this is just going to be random between the 4 legal actions. We are going to step this action. And remember, this is going to return the next observation, the reward, if it's done, and if it's truncated. Then we are going to set the next observation and the episode reward. So episode reward is going to be added, and obs is going to be set to next obs. Finally, we are going to render for visualization, and we should actually call render up here too to render it after it resets. Finally, after an episode is over, we append the reward to records. So episode rewards dot append episode reward. And then at the end, we are going to close our environment. And let's just print out the rewards we got. Great. Now that we're done with our main scripts, let's open up a terminal and let's run it. Oh, it looks like I made a mistake somewhere. Yes, we need to fix range here. Oh, also this, we want these to be filled in. There shouldn't be any width. Just make sure I haven't done anything wrong either. Oh, these colors are wrong. It's a easy mistake. It's RGB. All right, let's try that again. And there we have it. We have a player moving randomly. It's going to run for 2 episodes, right, till max step. Right now he's running into the walls, and max step happened, and there you go. So that first 1 max steps happened, so the environment got reset. And then in the second one, the player was able to reach the goal, and you could see the episode rewards for our kind of our loop. First time, right, truncated. Episode ended before he got the reward. Second one, he got the reward. Done was probably set to true. And yeah, this was a very simple example of a full reinforcement learning environment. In the next couple of videos, I'm going to introduce simple agent that we could train on this environment, and we're going to see what that looks like. Thank you for watching, and stay tuned for future videos.